Okay, so let's take this example. We have this example here. Two numbers are in the ratio 2:3. 4 we subtracted from each. They are in the ratio 3:5. Now here we need to revive what we learned. That if two numbers are in the ratio 2:3, you're not going to take them as 2 and 3. They could be 4 and 9. They could be 10 and 15. They could be 12 and 18. Anything. Whatever it is, if two numbers are in the ratio 2:3, we take the numbers as 2x and 3x. So hence the numbers are 2x and 3x. So we take the numbers as 2x and 3x. 4 is subtracted from each. So we have 2x minus 4 and 3x minus 4, and you're taking the ratio. So you're taking 2x minus 4 upon 3x minus 4, and this new ratio turns out to be 3/5. And we need to find the numbers which are in the ratio 2:3. We just need to find the value of x, the common ratio factor. We need to find this and substitute, and 2 into that and 3 into that will give you the number. So let's cross multiply quickly. 5 into 2x, 10x. 5 into minus 4, minus 20. 3 into 3x, 9x. 3 into minus 4 is minus 12. I think we can start doing things faster. So 10x minus 9x you have, and here you have minus 12 plus 20. So you have x is 8. So obviously 2x is going to be 2 into 8, 16. And 3x, that is this, is going to be 3 into x, that is 3 into 8, 24. So the numbers are 16 and 24. You can check it up and see 16 and 24 are in the ratio 2:3. Subtract 4 from each, you get 12, and you have 20. Cancel this by 4 and you get 3:5. So from 16 and 25 you subtract 4, you get the ratio as 12, the numbers as 12:20, which are in the ratio 3:5. So our answer is going to be 16:24, and I'm sure it's going to be the first option here. Yes, and yes, the ratio is, the numbers are 16 and 24. Let's check the next example, what we have. Okay, so we have angles of a triangle are in the ratio 2:7:11. The angles are what among these? Now here, actual calculation, we have a better way of doing it. Remember one thing, whichever are the angles, each of these angles should be multiples of 2, 7 and 11. So if you look at this one, 90 is not a multiple of 11, so this definitely does not make any sense. Again, 80 is not a multiple of 11, this makes no sense. Now let's check this orally. 18, 63 and 99. 99 divided by 11 is 9. 63 divided by 7 is 9. 18 divided by 2 is also 9. So that means that there is a common ratio factor 9 to all these, and each of them is divisible by 2. Each of them, if you look at it, is going to be divisible by 2 or 7 or 11. So without calculating these kind of cases, by the process of elimination, we have eliminated this particular case because the last term is not a multiple of 11. And these ones you can divide by the terms and you get a constant number. So this could be the option. So definitely 18, 63 and 99 are in the ratio 2:7:11. So among these, this is the best option. Let's check the answer. Yes, that is the answer. So there are cases we'll come across where to save on time, we can do the process of elimination rather than substituting it. Because if you look at it in this case, if you say 2x plus 7x plus 11x is 180 and go about doing it, it's going to take a longer time. So let's logically sit and calculate in such cases. Let's take the next example. Okay. Here we have a case wherein the number which when subtracted from each of the terms. Now you need to be careful over here. Here we are not going to take the numbers as 19 and 31 because it's told from each of the terms. So that means we'll take in 19 and 31 in actuality. So if you look at 19 as per the condition, you are subtracting an unknown x. From 31 you're subtracting an unknown x, and you get the final ratio as 1/4. So if you you need to find out this number which you're going to multiply. So you get 19 fours as 19 into 4, 76 minus 4x is equal to 31 minus x. So you have 76 minus 31 is equal to minus x plus 4x, 3x. So x will turn out to be 45 upon 3, which is 15. So the number which you subtract from each of these, you can check it up. 19 minus 15 is 4. 31 minus 15 is 16. 4 by 16 is 1 by 4. So the number that is going to be subtracted from each of these terms is going to be 15. And the answer is going to be 15. Let's check. Yes, we have the answer as 15. So in this example, I repeat, you're not going to take them as 19x and 31x because it's very clearly told it is subtracting from the terms, that is from the antecedent and the consequent, not from the actual quantities. Let's take the next sum. Okay. Two numbers are in the ratio 2:3 and the difference of their squares is 320. The numbers are what? Now here it's told about the numbers, not the terms. So you take the numbers as 2x and 3x and the difference of their squares. So obviously the square of this minus the square of this. So square of 3x is 9x square minus 2x, the whole square, that is going to be 4x square. This is turning out to be 320 and you get 5x square is 320 and you get x square is 320 by 5, which is 64. X square is 64, so x is going to be 8. So the numbers are 2 into 8, 16 and 3 into 8, 24. So our answer is going to be 16. So the numbers are 16 and 24, which on squaring and subtracting, you get the difference as 320. So our answer is going to be 16 and 24. Oh yes, we do have that answer. So further, we move over to the next sum. Let's get a little more strong in the fundamentals. So here we have a case of x is to y is 3:4. You need to find the value of this complex thing, x square y plus xy square is to x cube plus y cube. Now normally what we do is that we can take, if x is to y is 3:4, we take it as 3k and 4k. But in this case, since it's a further ratio, you can even cancel away the k. You can just substitute the values of x as 3 and y as 4 because we are finding the value of a further ratio itself. But when you look at this thing, this can be further simplified. If you see x square y plus xy square is nothing but xy into x plus y. And this is going to be x plus y into x square minus xy plus y square. So whenever you get a complex expression, check if you can further simplify. So here if you see this term gets cancelled and you're left with xy upon this. Now x is not actually 3 and y is not actually 4, but since we're going to find a ratio from another ratio, we can substitute x as 3 and y as 4. So we get 3 into 4. X square, that is 3 square 9, minus xy, which you calculated here already, which is going to be 12, plus y square, that is 4 square, which is 16. So that gives you 12 upon 16 plus 9, 25 minus 12, 13. So our answer is going to be 12:15. Do we have that here? Oh yes, we have this. So if x is to y is 3:4, the value of x square y plus xy square plus x cube plus y cube is 12:13. Yes? Yes, it is 12:13. Let's check the next example, which is similar to this, but this is having a little more of extra things over here. So if you see p is to q is 2:3, x is to y is 4:5, 5px plus 3qy is to 10px plus 4qy. Now, if you say 5px plus 3qy, I repeat what we learned last time in the previous example. We normally, if you take p is to q as 2:3, we have to take P as 2K and Q as 3K. Similarly, this would be, say, X is 4M and Y is to 5M. But again, I emphasize on this, we are going to find the value of another ratio. So even if you substitute P as 2K, 3K, 4M, 5M, when you take the ratio, the K terms, you get a KM and the KM, they are bound to get cancelled, and ultimately it's just going to be equivalent to substituting X as 4, Y as 5, P as 2 and Q as 3. So whenever you need to find the value of another ratio from the given ratios, we can substitute the values of the terms as they are. You need have to take them as 2K and 3K. We do all those only if you have to find the difference of the numbers or if you have to find the sum of the numbers. So let's go ahead with this. So we have 5px plus 3qy. So it's a combination of compounding a ratio. So you have 5px. So it's going to be 5p is 2, x is 4. I repeat, actually x is 4k, but things are bound to get cancelled. As I told, the km part will get cancelled. So that's 5px plus 3qy. So it's going to be 3 into 3 into 5. So that gives you this part, and is 2. So denominator turns out to be 10px. So 10 into 2 into 4 plus 4 into q into y. So 4 into 3 into 5. So that turns out to be 5 2s are 10, 40 plus 45 upon 80 plus 4 3s are 20 into 5, 60. So that gives you 85 upon 140, cancelled by 5, and you get 17. And 140 divided by 5 is 28. So our answer is going to be 17 is to 28. Let's check what we answers. No, not this, not this, and we have 17 is to 28. So in such a case, the value of this expression is 17 is to 28. Since these two problems were similar, I emphasize once again, since we are finding, if you look at it, if you had substituted this as K and M, you would have got 85 km upon 140 km. Km in any case would have got cancelled because it's a common ratio factor. So in such a case, since we are also dealing with MCQ, we can skip away the K because we are finding the value of a ratio from the given ratio. Hence, we can take the terms as they are. So thus we have the cases. Now here we have something slightly move into proportions, which are going to take up more detail in the other, but let's give a quick cut. Now we are talking about the proportion concept. Now what you mean by proportion? Suppose you have two ratios, A by B and C by D, and if these ratios are equal, that means A is to B is equal to C is to D, then we say that the terms A, B, C and D are in proportion. They are in proportion, and in the same order, this is called the first proportional, this is called the second proportional, this is called the third proportional, this is called the fourth proportional. So if two ratios A by B, C by D are equal, then the antecedent, they are said to be in proportion, and the antecedent of the first term, that the first ratio is the first proportional, its consequent is the second proportional, the antecedent of the second ratio is the third proportional, and this is the fourth proportional, the consequent of the second ratio. But here we have a catch, the third proportional between A square minus B square and A plus B the whole square. Now here the inbuilt assumption is that there is, in the second set of ratios, this itself is repeated, which means that A square minus B square is the first proportional upon A plus B the whole square. And for the second ratio, the consequent becomes the antecedent, and the last one would be called the third proportional. And we call this as X, which is what we need to find. Now, if you look at it later on, we'll be coming across this. We have two terms, and we want to find the third proportional, which also means that a square minus b square, a plus b the whole square, and x are in what is called as continued proportion, which means that the second term is said to be the mean proportional of these two. So please understand that whenever we need to find the third proportional of two numbers, we first find the ratio of the given two numbers, equate them with another ratio whose antecedent is just repeated as a second term, and you find this. So now we need to find the value of x. So x is going to be a plus b the whole square into a plus b the whole square upon a square minus b square, which can be written as a minus b into a plus b. And this gets cancelled, and you ultimately get a plus b the whole cube upon a minus b. So x turns out to be a plus b the whole cube upon a minus b, and which means that x is the third proportional between these two numbers, which also means that the second number is a mean proportional between this a square minus b square and the unknown x. We will take up the concept of mean proportional when we take up proportions, but thus just give a first bird's eye view of what it means when you need to find the third proportional of two numbers. So if you look at it, our solution is a plus b the whole cube upon a minus b, and where do we have it here? Oh yes, so we have a plus b the whole cube upon a minus b is the third proportional between these two terms. Let's check our answer. And yes, a plus b the whole cube upon a minus b is the third proportional. Now, the next one is a little bit about number system. It's a little off, but let's just understand. The recurring decimal 2.777 can be expressed as what? As which among these fractions? Now, what do you understand by recurring decimal? We need to find the value of this in terms of a fraction. If you have something like this, you want to convert it to a fraction, you can write it as 25 by 10, which is the same as 5 by 2, because it's a terminating decimal. But suppose you have something like this, how do we do it? So let's take x, let this be x, it means it is x is equal to 2.7777, whatever it is. Now what we will do is we will try to eliminate away this recurring part of it. So for this we take multiply, since there is only one decimal place that is repeating, we multiply both sides of this equation by 10, and you have 10x, and this side, if you look at it, it becomes 27.7777. So if you see, the recurring part is gone on one side. Now from this we need to find the value of x, so just subtract the equations. When you subtract the equations, you get 10x minus x, and this side it is 27.77 minus 2.777. Obviously the 0.77 part gets eliminated, and ultimately it's just 27 minus 2, which is 25, and here you have 9x. So x is 25 by 9, and if you actually divide and see 25 by 9, you're bound to get 2.777. So the recurring decimal 2.7777 can be written as a ratio 25 by 9. Now, as I told you, this is a little off track compared to the other sums, but it's essential for us to understand. Maybe we could just take another simple example. Say we have 3.33333. We need to find this as, convert this to a fraction. You can take x as 3.333. So we will have 10x as 33.33333. So now if you subtract 10x minus x is 9x. 33.3333 give you 30.33 part gets cancelled, and it's 33 minus 3, 30. So x is 30 upon 9. So thus we can convert this. Is just using whatever we learned in the earlier classes in your high school level. Now this is the logical way of doing it. But in the exam you have an advantageous situation. You have a calc with you. So you calculate 26 by 9. It's not going to be turning out to be 2.77. 22 by 9 is not this. 24 by 9 is not this. 25 by 11 is going to be 2.777. You can check it up with your Cal-C. So this is an elimination process. Since you have a calculator with you, you can actually divide 26 by 9 and find out. Now here, why have we included this in ratio? Just to make you understand that for practical purposes, a ratio 26 by 9 for mathematical calculation is the same as a fraction. Hence it is 26 divided by 9. So the logic is this, but for the exams, to save on time, you can actually calculate and find this out. So smarter way of doing it. Right, let's see what we have further. So what do we have in the next one? Yes, a slightly different concept. You have the concept. Let's read this question and then we'll understand the concept. X varies inversely as square of y, and given that y is equal to 2 for x is equal to 1, then what will be the value of x for y is equal to 6? Now this is a case of variation. Now whenever you have a case of variation, either one quantity increases, say x increases, and the other one also increases proportionately. Or if one quantity increases and the second one decreases proportionately, then you have the concept of variation. Now when you have x varies inversely, it means that when x increases, the square of y decreases proportionately. For example, if x becomes double, the square of y will become half. So which also means that whenever you have a case of inverse variation, the product of the variables involved, that is in this case x and square of y, not just y, this is a constant. That means for various values of x and y square, the product remains a constant. It's like telling, if you want to cover a particular distance, you increase the speed, the time will decrease proportionately. You decrease the speed, the time will increase proportionally, so that the product of them, the distance, remains the same. So which also means that x1 into y1 square is equal to x2 into y2 square. Since we have two values of y's and two values of x, one of which we need to find, we can use this principle. So the first set of x and y is, so x1 is going to be 1, so it's going to be 1 into y1 square, that is 2 square, is equal to x2, which we don't know, into y2 square, that is 6 square. So that means x2 is going to be 2 square, 4 upon 36. So x2 is 1 by 9. So the value of x for y is equal to 6 is 1 by 9. So I repeat, whenever you have a case of x varying inversely as y or square of y or cube of y, it means the product is constant. Suppose you say in the same example or a similar example, x varies inversely as cube of y. In that case, it's going to be xy cube is a constant. This is a constant, which means x1 y1 cube is equal to x2 y2 cube is equal to x3 y3 cube, and so on and so forth. Umpteen number of pairs of x and y values you take, multiply x with the corresponding y cube. All the cases you'll find the value is the same, which means that it's a case of inverse variation. So coming back to our solution, the solution for this case is 1 by 9. That means when y is 6 for this particular relationship, x has to be 1 by 9. So the answer is 1 by 9. Let's see what we have with us. Yes, the answer is 1 by 9. Now let's take a sum similar to that, to this inverse variation concept or direct variation. We'll take an example of direct variation and see what we have. Now here you have a case of x varies directly as square root of y. Now this is a case of direct variation, which means that if one quantity increases, the other quantity also increases proportionately. Take the case of distance and time. You have a particular speed. If you are to cover a greater distance, you have to increase the time. It'll take more time to cover the different distances with the same speed. So distance and time are a case of direct variation. Now whenever you have a case of direct variation, in case of inverse variation, the product of the variables was a constant. Here the ratio of the variables is a constant. That means x varies directly as square root of y would mean that x upon root y is a constant. This is a constant, which would mean x1 upon root y1 is equal to x2 upon root y2 is equal to x3 upon root y3, but we don't have the third set of values, we just have two sets of values. So our x1 is going to be 3, so we have 3. Our y1 is going to be 16, so it's going to be root 16. Mind you, it's not 16, it's going to be root 16 because x varies directly as square root of y is going to be x2 upon y2. Now we do not know what x2 is, and y2 is going to be root 144. So that turns out to be x2 turns out to be 3 upon root 16, that is 3 by 4 into root 144, which is 12. So 4, 3, and x2 turns out to be 9. In other words, when y is 144 and if x varies directly as square root of y, in that case x has to be 9. Let's check whether we have it right or no. And yes, we do have it as 9.